Hello students, today we will discuss about one more topic which is dielectric constant represented by K or epsilon r. As on the last term we have discussed about the Coulomb's law, and the mathematical form of Coulomb's law in vacuum is given by this relation F naught equals to 1 over 4 pi epsilon naught Q1 Q2 over R square. What happens if you have a medium other than air or vacuum? Means for any medium which is other than air or vacuum, the Coulomb force is given by this relation in which this epsilon naught gets replaced with this epsilon, where epsilon we call as the permittivity of the medium. This we call as permittivity of the medium, and the value of epsilon depends upon the medium. What kind of medium we have? Either the medium is air, either the medium is water, either medium is mica, and so on. The value varies accordingly. So if you divide this F naught with Fn, we have epsilon over epsilon naught, which will be further equals to K, which we call as a dielectric constant and also given by epsilon r. We read this as the relative permittivity of the medium. Relative permittivity of the medium. So if we consider the values of K, for vacuum we have the K as 1, and for water K we have as 81. So accordingly the force between charges varies depending upon the nature of medium. Now the next topic we have to discuss is about the electric field. Electric field. I think you all have idea of the magnetic field produced due to a magnet. As that of magnetic field, we have the electric field also, which is simply the region around a charge where another charge experiences a force of attraction or repulsion. So electric field given by capital E, and it is a vector quantity, so you have to place a vector sign here. What this electric field is? It is the region around a charge where another charge experiences a force of attraction or repulsion. It is given by 1 over 4 pi epsilon naught Q over R square. That is, if we relate this relation with the Coulomb force, we have F or E equals to F over Q naught. And accordingly, the SI unit of field is, as the SI unit for force is Newton and for charge is Coulomb. So Newton per Coulomb becomes the SI unit of electric field. If we talk about the field lines, electric field lines, which are around any charge. So if we have a positive charge, we can have the electric field lines coming out from the positive charge, and if the charge is negative, the field lines, this is for positive charge if charge is greater than 0, and for negative charge in the same manner the field lines are into the charge, and if we have the combination of charges, this is for the case when charge is less than 0. If you have a positive and negative charge both, or you may consider this as dipole, so this charge is say Q, this is say minus Q, then what kind of field lines pattern are there around this combination? So as these two charges will attract one another, so field lines comes out from positive charge and enters into the negative charge. So you have a field like this. From positive charge, field lines are coming out, and in negative charge, they are entering in. So this is the representation of the electric field lines around a charge combination. Now, if we talk about the properties of field lines, you all are familiar with the properties of field line also, and the important properties are that the field lines starts from a positive charge, and ends at the negative charge, or you may say that these are not like the magnetic field lines. These are not like the magnetic field lines. Field lines are the continuous curves because they are appearing from here and reaches here, but they are not closed because these lines are not returning. So field lines are the continuous curves but not the closed one. Two field lines can never intersect. Why? Because electric field being a vector quantity cannot have two values at a point. Cannot have two directions of electric field at a point, as electric field is a vector quantity. And after this, we will discuss few more terms. And out of those, one term is the area vector, and then we will talk about the electric flux. Very important terms. So let us discuss what is this area vector is. So area vector is simply the outward drawn normal to any surface. Area vector is the outward drawn normal to any surface. Area vector. Suppose you have this area, plane surface, and this is the normal to the surface represented by unit vector n, and the area of the surface is say ds or delta s, we may write. In some books you have delta s also. So the area vector delta s is given by delta s unit vector n. So how we can define area vector? It is the outward drawn normal to any surface. Note this thing. Outward drawn normal to any surface represents the area vector to that surface. We have to use this area vector while defining the electric flux. So next topic is simply the electric flux here. Represented by phi, and what this electric flux gives us? Electric flux gives the measure of field lines passing through a particular area of cross section. It gives the measure of field lines passing through a particular area of cross section. It is given by delta phi is equals to E dot delta S. This is the small flux due to small area, and if you want to write this the total flux, it will be phi equals to closed integral E dot ds. E dot ds. If you try to understand this by means of a figure, you can have, suppose these are the field lines coming from infinity, and these lines are for uniform field, and here you have placed some area like this. So the area vector is along this direction. This is delta s. So the angle between E and delta s is 0. So you have flux phi equals to integral E delta s cos 0. What is the value of cos 0? Cos 0 is 1. So you have phi as integral E delta s. The formula you have for the total flux. Now if we talk about the unit of flux, so in SI system, the unit of flux is Newton Coulomb inverse to meter to the power 2. You have the unit from here also. E, electric field, has the unit Newton per Coulomb, and delta S has the unit meter square, because this is simply the area. So the unit is Newton Coulomb inverse into meter square. So in the next lecture we have to discuss about the next topic, which is electric dipole. Thank you.